Welcome to this session. We have a problem to solve on determination of solution of a differential equation by matrix method. So we're going to describe how to express this given differential equation in the form x dot equals to ax. And then once we have our A matrix, we find the eigenvalues and then the eigenvectors, and then we get the linear combination of the solutions thereafter. So let's see how we do this. So solution. So we have that the x squared the x squared dt plus 4 dx dt minus 12x plus 4 dx dt minus 12x equals to 0. That's what we have been given in this problem. So the first step, when you have such a problem, make the highest derivative the subject of the differential equation. So we'll say dx squared or d squared x and then the t squared. So take this to the right hand side. So we'll have 12x minus 4 dx dt. And for convenience, because we know that writing dx dt is the same as writing x prime, and writing d squared x dt squared can be written as x double prime, then we can say this is the same as writing x double prime equals to 12x minus 4x prime. Now, once you have made the highest derivative the subject, then introduce new variables. So we let x variable used in this equation to be another variable x1, which means that x prime or the dx dt is the same as x1 prime. Okay, so once you have done that, then it means that what you have made the subject here, there's no mistake if you put 1 here, 1 here, and 1 here, because x is the same as x1. So once you have introduced the new variable x1, then you'll say this x1 prime, let it to be another new variable x2. Now at this point, you call this one equation 1. So let the derivative of x1 be called x2. So differentiating both sides of equation 1, we get actually to be x1 double prime equals to x2 prime. So it means that I'll call this one star. In this equation star, where there's x1 double prime, I can replace by x2 prime. So therefore you say star becomes x2 prime equals to 12x1 minus 4, but instead of writing x1 prime, you see x1 prime is x2 from equation 1. So you write x2. And therefore you call this one equation 2. Now, equation 1 and equation 2 are actually first order differential equations. So writing equation 1 as x1 prime can be written as 0x1 plus x2, and equation 2 can be written as x2 prime equals to 12x1 minus 4x2. So remember, this is still the equation 1. This is the same equation 2. Now you write the matrix equation for 1 and 2. So we'll have x1 prime, x2 prime is given by 0, 1, 12, minus 4. And then we call this one x1, x2. So this is now what we call the matrix equation. And you see now in this matrix equation is what is the same as x1 dot equal x dot equals to ax, where the x dot is this vector for first derivatives, a is this matrix, and then x is this vector. So therefore, a is 0, 1, 12, and minus 4. So this is the matrix of interest. So next, find eigenvalues. So eigenvalues will solve determinant of a minus lambda I equals to 0. So which will be determinant of 0 minus lambda 1, 12 minus 4 minus lambda equals to 0. And then I'll have negative lambda into minus 4 minus lambda minus 12 equals to 0. So 4 lambda plus lambda squared minus 12 equals to 0. This is the same thing as saying lambda squared plus 4 lambda minus 12 is 0. Product is minus 12. Sum is 4. So we need to get two numbers which will give us this product and sum. Numbers are minus 2 and 6. So that I have lambda squared minus 2 lambda plus 6 lambda minus 12 equals to 0. Common here is lambda. Lambda minus 2 plus 6 into lambda minus 2 equals to 0. So lambda plus 2, lambda minus 2 lambda minus 2 lambda plus 6 is equals to 0. So lambda 1 is 2, lambda 2 is minus 6. So this implies lambda 1 is 2 and lambda 2 is minus 6. Once you get the eigenvalues, get the eigenvectors. So you start by lambda 1 equals to 2. So we let the eigenvector to be of the form because these are 2 by 2 matrix, so we have u1, u2. So we have to solve the equation au1 equals to lambda 1 U1. So the A matrix is 0, 1, 12 minus 4 times the U matrix is U1, U2. And then we have 2, U1, U2. So we'll have 0 times U1 is 0, and then U2 equals to, okay, U2 is the first element in the numerator. So we have U2, and then we have 12 U1 minus 4 U2 to give us 2 U1, 2 U2. For this equality to make sense, then we expect U2 to be 2 U1 and 12 U1 minus 4 U2 to be 2 U2. Call this one equation 1, call this one equation 2. Now we fix from 1, let U1 be T, where T is a non-zero scalar, real scalar. Immediately we do that, we get U2 to be 2 U1, 2T, 2 U1. So then U1 vector is U1, U2, which is given by T, 2T, which is 1, 2, and then T. T remains to be a non-zero scalar. Now, in particular, if we let T to be 1, then this vector will be 1, 2. Now, once you get the eigenvector for lambda 1, then you get the corresponding solution. So x1 of T is usually given by U1 e raised power lambda 1 T. So this will be 1, 2, and then e raised power lambda in this case was 2. So 2T. So call this one star. So let's go to the second eigenvalue. So lambda 2 equals to minus 6. So let eigenvector be U1, U2. You expect to have this equation satisfied. So pick your matrix A, which is 0, 1, 12, minus 4, multiply by this vector, U1, U2, should give you minus 6, U1, U2. So we'll have U2 and then 12 U1 minus 4 U2 to be given by minus 6 U1 minus 6 U2. The only way this equality can make sense is when U2 is minus 6 U1 and 12 U1 minus 4 U2 is minus 6 U2. This equation 1, this equation 2. So from 1, we have we let U1 to be S, where S is a non-zero scalar. So by doing that, U2 will be negative 6s. So then the vector U2 will be U1, U2, which is S and then minus 6s, which you can write it as 1 minus 6 times S. S is a non-zero scalar. And then in particular, letting S to be 1, this implies that our U2 will be the vector 1 minus 6. So the solution x2 of t is U2 e raised to power lambda 2t, which is given by 1 minus 6 e raised power lambda 2 is minus 6, then t. So call this one as double star because we have. And then by superposition principle, the general solution is x of t is given by C1 x1 plus C2 x2. So you get x of t to be C1, and then the first vector was 1, 2, and then times e raised power 2t plus C2. Then this other vector is 1 minus 6 e raised power minus 6t. If we were not given the initial conditions, then we stop at this point. But because in this same question, we've been told that x of 0 is given by 0 and x prime of 0 is given by 8, then these two conditions in vector form will be written as x of 0 is the first row become the function value, the second row is the derivative of the function value. So that is the interpretation of these initial conditions. So therefore, you say whenever you put t for 0, you get 0, 8. So 0, 8 will be the value when t is 0. So putting t 0 here, we get e raised power 0, which is 1. This also e raised power 0 will be 1. So just have C1, 1, 2, plus C2, and then 1 minus 6. So when you solve this, you get 0, 8 equals to C1 plus C2, 2C1 minus 6C2. And as usual, for this equality to make sense, then row 1, C1 plus C2 should be 0. And then 2C1 minus 6C2 should be 8. So call this equation 1, call this one equation 2. From 1, it implies that C1 is minus C2. So using this substitution in equation 2, we'll have where the C1 we put minus C2, so we'll have minus 2C2 minus 6C2 equals to 8. This is the same thing as saying minus 8C2 equals to 8, which implies C2 is minus 1. And then it's the same thing as saying C1 is positive 1. So therefore, the particular solution to the equation x dot equals to ax is x of t, capital X of t. C1 is 1, so just have 1 to e raised power 2t. C2 is minus 1, so minus 1 minus 6. And then e raised power minus 2 minus 6t. So putting together, we get e raised power 2t minus e raised power minus 6t, and then 2 e raised power 2t. Now minus minus is plus, 6 e raised power minus 6t. So note that this is the solution for the general x, capital X of t. But the first row is what shows this is the value for x1, and this is the value for x2. So x2 corresponds to the derivative of x1. So to give now the solution to the given differential equation, you pick the answer you get in the first row. Actually, this capital X of t means x1 of t, x2 of t, which will be now e raised power 2t minus e raised power minus 6t, 2 e raised power 2t plus 6 e raised power minus 6t. And you see that this is the same thing as saying this was the x of t value, and this is the derivative. So therefore, to pick out the correct solution for the given differential equation, because we're interested in finding the value of x of t, you pick this first row. So you say, hence, the solution to the given initial value problem is x of t. You pick what you have on the first row, e raised power 2t minus e raised power minus 6t. So this is what is the answer to the solution. This other second part is just to show the derivative of the solution you have. You can clearly see that if you get the derivative of this function, you get this one. So this is where you have to stop. So that is the answer to the given differential question. Thank you.